Hi everyone, in this video we are going to talk about borrowing and references, which is an extension lesson on our ownership. In Rust, the concept of ownership ensures that each value has only one owner, preventing common memory-related bugs. However, sometimes you may need to access a value without owning it, and that's where borrowing and references come into play. Borrowing is a way to temporarily access a value without owning it. It involves creating a reference to the value, which enables you to read or modify it without becoming its owner. Unlike owned values, references are lightweight and efficient. To create a borrow in Rust, you use a reference which is a pointer to the value that's guaranteed to be valid and safe by the compiler. Rust has two types of references, and these are mutable and immutable. So let's start with immutable references. First, I'm going to create a string here. I will say my string, and we are going to say hello world here. And then I'm going to create an immutable reference for this. I will say my ref here, and then we will say my string. Here what we did is we created an immutable reference to our string here. If you remember from the previous lesson, once we created a reference, we were putting this reference to the stack, but we were referencing to the value which is on the heap. So to get the value on the heap from here, we would go to the stack and we would take the reference of this variable and we would go to this place. But here we only have the reference, which is an immutable and read-only reference. So we can get the value of my string hello world using this reference here, but we cannot modify the value through this myref here. So if I say println my reference is, and we say my ref here, and we say cargo build, and then we will say cargo run. As you can see, it says my reference is hello world, so we can get value through this reference. Now let's create a function which takes a string reference as a parameter. My parameter will be s, and which is a string reference. And here we will say println the value we have, and done. So what we do is we are just printing the parameter that we got. So if we said string instead of the reference here, what would we have is a string as the parameter, and then after printing the string here, at the end of this function, we would deallocate the space, meaning that the string would not be accessible because we are just deleting that space. But since we are using the reference, what will be deleted is the reference so that we can continue using the string. So let's use this function. Up here, we are going to copy this again so that we can see how we use them together. And down here, I'm going to say print string. And as a parameter, I'm going to pass my string's reference here. So as you can see, I didn't need to create another variable. I'm just passing my string with this ampersand here, which is the reference. So if you print this here, as you can see, what we get is hello world. So what happened is we lost this reference here after this function since the memory is deallocated, but since we didn't use my string here, we can print out the string again. Let's say I still got my string. I'm going to say my string, and if we run here, as you can see, we got hello world, and I still got my string hello string. We can have multiple immutable reference to a value which is called aliasing, but we cannot have an immutable and mutable reference at the same time pointing to the same value. Because if we think logically, with immutable reference, we are saying this, I'm getting this reference, I'm just going to read this, so I know that the value I got is not going to change since it's an immutable reference. And then at the same time, we are saying I have a mutable reference, so I may change the variable through this reference. So if we have these two references at the same time, on one hand, what we have is a value that we think is not going to change, and on the other hand, what we have is another value that may change, and they are pointing the same thing, which is not consistent. So we cannot have immutable and mutable variables at the same time, but we can have numerous immutable variables to a value. Now let's talk about mutable references. So mutable references are like immutable references, but the difference is, which is obvious, they are mutable, so we can change the variable through these references. Now let's create a function here for our mutable reference example. Let's call this function change string, and we are going to take a parameter which is a mutable reference. Then we will say s.pushStr, which adds to our string world. And as you can see, we are trying to create hello world, which is our favorite phrase, I guess. Now I'm going to create a mutable string here. Let's call it my string. And we are going to say hello here. Then we are going to say change string, and we are going to pass mutable reference to my string here. And then we are going to print out the value of my string. So we can see that it has changed. Then we will say my string here. So let's run this code and then talk about it. So let's run this code and see how it goes. Let's say cargo run. And here what we have is hello world. So what happened here? We created a mutable string, which means that I created a string, but I want to change this later. So I said mute here. Then with my function, I passed this value as a mutable reference. After we got the mutable reference here, we are adding world to it. Then after this line has executed, we are printing out the value. And through this reference that we took as a parameter and we passed here, as you can see, we were able to alter our original string through this mutable reference. That's why it's a problem to have mutable and immutable reference at the same time, because we can change the variable itself through this mutable reference. And since we have the immutable saying that we are not going to change this variable, we are expecting to use this as it is throughout the program. This creates a conflict so that Rust bans this. Now let's create an example where we have multiple immutable references. For that, I'm going to say let first immutable reference equals, let's use my string. Then we are going to create the second. And next we are going to println this value. I will say first immutable reference value and second immutable reference value. And we are going to say first immutable reference and second immutable reference. Let's say cargo run here and comment out this line so it wouldn't interfere. Now what we have is first immutable reference value hello world, second immutable reference value hello world. As you can see, we are able to use multiple immutable reference to the same variable. Now let's create immutable and mutable reference to a variable at the same time. Let's say let first mutable reference equals, I'm going to say my string here. So we created a mutable reference for our string, and then we are going to say println first mutable reference value and our first mutable reference. And let's run this. First mutable reference value hello world. So what I said was we cannot have mutable and immutable references at the same time. But once we look at here, what we have is a mutable reference and immutable reference, and it looks like our code works without any problem. But now I'm going to say println immutable reference value, and then I'm going to say first immutable reference. Then I'm going to say cargo check. As you can see, what we got is could not compile borrowing and reference due to previous errors. And let's see what these errors are. It says that mutable borrows occur here and immutable borrows occur here. And it talks about having mutable and immutable borrowing at the same time. But even before this line, we had immutable and mutable references at the same time. So why it gives an error now, but it didn't give error before? So the difference is that we can actually have mutable and immutable reference to a variable at the same time. But after we created this mutable reference, then we tried to use the immutable reference. So in Rust eyes, after we create this mutable reference, the first immutable reference is no longer valid. So once we try to use the immutable reference 2 with the mutable reference on our hand, then we create the problem. So Rust is intelligent enough to understand we can have these two at the same time. if we are not going to use immutable reference from now on. So there wouldn't be any conflict. But once we try to use the immutable reference, then it creates a situation having immutable and mutable reference at the same time, then we have the problem. So as long as we are not using the first immutable reference, we can have mutable reference to the same variable. But since it's a very problematic and risky situation, what we do is we do not create immutable and mutable reference at the same time to a variable. So let's see what happens when we have multiple mutable variables. Here I'm going to say let second mutable reference, and then I will say mute my string. Now we have two mutable references to a variable, and let's see what happens with cargo check. And as you can see, we were able to pass our cargo check, and then let's print this value. Here I'm going to say second mutable reference, and now it also passed our cargo check. If we say cargo build, it also passes our cargo build, and now let's say cargo run. And as you can see, we were able to run this without any problem. Here it says hello world. So since we haven't used our first mutable variable after creating and using our second mutable variable, there was no problem. But if I take this line again and put this line here under this, and if we say cargo check again, as you can see, now we have a problem. Second mutable occurs here. So with the same ideology, after we got our second mutable reference, we cannot use our first mutable reference. Once the conflict starts, Rust puts a stop to this. So not to get confused with these tiny details, we have our guide to use these references. So our first rule is that you can have either one mutable reference or any number of immutable reference to a variable at a time. Second, you cannot have both a mutable and immutable reference to the same variable at the same time. The third, references must always be valid and point to a valid memory location. And fourth, references automatically expire at the end of their scope. We talked about how we are deallocating memory location in the functions of our parameter, and we also talked that how we cannot have two mutable reference to a variable or one immutable and mutable reference to a variable. What we can have is the only multiple immutable reference to a variable. But we haven't talked about the third one, which is references must always be valid and point to a valid memory location. For this, we are going to look at the dangling reference example. In Rust, a dangling reference is a reference that points to a memory location that has been deallocated, causing unexpected behavior or a runtime error. This can happen when a reference is still in the scope after the object it refers to has been dropped. So create a function where this situation would happen. Here, I'm going to create my function and I will call it return reference. And I have some string here, and its type is string reference, which returns a string reference. And I will return some string here. Now let's use this function. Here I'm going to create a new string. Let's say new string. Let's call it new string. And then we are going to use this function. For that, I'm going to say new string reference, and then I'm going to say return reference, and I'm going to pass this new string here. So we created a string here and we pass this here, and what we get is the reference of this string. Here I cleared out our terminal so it's easier for us to see. Now let's comment this so it wouldn't give us an error. So now I have a string, and through this function I have a reference to this string. Now let's print out this. I'm going to say our new string, then I'm going to say new string, and here I will say cargo run, and it runs without any problem. Now I'm going to comment this out and I will say let's say newer string, which equals to new string. Now, after we say this, the ownership moves to the newer string and we allocate the memory of the new string so that our two different pointers wouldn't point the same memory on the heap. Now, what we have with this new string reference is we have a reference to this string here, but which is now deallocated. So once we say println and then we say new string reference, then we say new string ref, and we run this. As you can see, move out of new string occurs here. So in this line, we are moving the value, and this line we are trying to use it. So through this function, what we got is a reference, that's a dangling reference, where the space can be deallocated from some other function, and with the reference we have, wouldn't point anywhere. So this is a common problem, and we should be really careful about this, and that's why we have the third rule, which is the references must always be valid and point to a valid memory location. I know it's too much to grasp at one time, but while we are using this in our later lessons, it's going to be more intuitive and much easier than it looks now. So, thank you very much, and I will see you on the next one.